For the circuit shown below, find the potential difference between P and Q. This is the given circuit. Here we are supposed to find the potential difference between node P and node Q. Let me redraw the circuit. So this is the given circuit. We can assume that this node is P. I will assume voltage available at this node is, say, Vp, and voltage at this node Q is, say, it is Vq. Let me call this as node T. Voltage at this node is, say, Vt. So now the potential difference between Vp and Vq is represented as Vpq, which is equal to voltage at P node minus voltage at Q node. This is nothing but potential difference between node P and node Q. So here we can observe that voltage source of 10 volt is directly connected to node T and reference node. Therefore, we can say that Vt is equal to 10 volts. So now we are supposed to calculate voltage available at node P and voltage available at node Q. Let me solve this using nodal analysis. So I will assume let current through this node is I1, current through this branch is I2, let current through this branch is I3, let current through this branch is I4. Now let me apply KCL to node Vp, that is apply Kirchhoff's current law to node Vp. We know that in KCL incoming current is equal to outgoing current. Here we can observe that at node P all are outgoing current, there is no incoming current. So incoming current is 0. So I will consider outgoing current as positive. Therefore I can write I1 plus I2 plus 2 is equal to 0. We know that according to Ohm's law, V is equal to IR. Therefore, current can be expressed as V by R. Now let me express all currents in terms of voltages. So I1 is the current which is flowing from node Vp. So I1 is nothing but Vp divided by 8. So I1 is Vp divided by 8 plus I2 is nothing but the current flowing from node Vp towards node Vt. So we can represent it as Vp minus Vt divided by 2, and here we have plus 2 is equal to 0. Let me simplify this. That is Vp by 8 plus Vp by 2 minus Vt is nothing but 10 volt. That is 10 by 2 plus 2 is equal to 0. Let me simplify this further. That is Vp by 8 plus Vp by 2 minus 5 plus 2 is equal to 0. So let me simplify this further, or I can write it as Vp by 8, or I can write it as Vp in bracket 1 by 8 plus 1 by 2 is equal to, here we have minus 5 plus 2 is minus 3. That is minus 3 is equal to 0. Or I can write it as 1 by 8 plus 1 by 2. It gives 0.625. That is Vp is equal to 3. Therefore, I can write Vp is equal to 3 divided by 0.625. Solving this will get 4.8. So therefore, Vp is equal to 4.8 volts. So now we found Vp value. Now similarly we will calculate Vq. So to find Vq, I will apply KCL to node Q. That is, now apply KCL to node Vq. So here we can observe that I3 current is incoming current to Vq, 2 amp is incoming, and I4 is leaving the node Vq. So I can write 2 plus we have I3 is equal to I4. I3 is equal to I4, or I can write it as 2 plus So here I3 is nothing but Vt minus Vq divided by 4. That is Vt minus Vq divided by 4 is equal to, so I4 is nothing but Vq divided by 6. That is Vq divided by 6. Simplifying this, 2 plus Vt is 10. That is Vt by 4 minus Vq by 4 is equal to Vq by 6, or I can represent it as 2 plus Vt is 10 divided by 4 minus, or I can take Vq on other side, that is Vq by 6 plus Vq by 4. So here I can write it as 2 plus 2.5 is equal to, we have Vq in bracket 1 by 6 plus 1 by 4, or I can write it as 4.5 is equal to Vq into 1 by 6 plus 1 by 4, it gives 0.41667. So therefore here I can write Vq is equal to 4.5 divided by 0.41667. So simplifying this, will get Vq equal to, it gives 10.8 volts. So therefore now according to this formula, Vpq is equal to Vp minus Vq. That is potential difference between P and Q is Vpq is equal to Vp minus Vq. Therefore we have Vpq is equal to, Vp is already found, that is 4.8 minus 10.8. Therefore Vpq is equal to minus 6 volt. This is the potential difference between node P and node Q, that is minus 6 volts. Thank you for watching.